And what about overdamped motion, which means like you have like a too strong damping term, right? Then like think about like a really strong spring as like suspension of your tire, okay? And it's really like thick and strong spring, which is even you just stretch out a little bit, and when you let it go, it never be oscillate, but like it goes back to the like equilibrium position, right? And that strong part. In other words, your damping coefficient gamma is strong enough. Okay, so like overdamped means the case your gamma square minus 4 mk, like as I told you, like gamma, which is damping coefficient really strong, which is big number, then it will be positive. Okay, so if your gamma square minus 4 mk positive, in other words, your gamma square is bigger than 4 mk, definitely you're gonna have like positive number under the square root part of your characteristic equation. Okay, let me rewrite your characteristic again. Your R is equal to minus gamma over 2m and plus and minus and square root of gamma square minus 4 mk over 2m, okay? And like both of them are the real number, then we can say your R1 is minus gamma over 2m plus square root of gamma square minus 4 mk over 2m, and R2 is minus gamma 2m minus and square root of gamma square minus 4 mk over 2m. Okay, then since like both of them is a real number, and those R1 and R2 will be the like exponent of your expansion function, right? So therefore, general solution is can be written by like this way: coefficient A times e to the R1t plus B times e to the R2t. That's it. That's it. Okay. But keep that in mind. Your R1 and R2s are negatives. Do you see what I'm saying? Can you verify this one? First of all, look at R2. R2 is like we know M and gamma and K, all of them is positive, okay? When you look at R2, at minus gamma over 2, which is negative value, and minus another like negative, right? So like this whole thing is negative. R2 is negative. What about R1? Minus gamma over 2M is definitely negative, but when you compare with the like plus term, that is positive number. But look at that. If you do not have like 4 mk, if you do have like this part, it will be just like gamma over 2m, which is exactly the same with the previous, okay? But you subtract 4 mk, which is positive value. So for second part, that part, like, this value is like gamma square minus 4 mk is less than gamma square. So which means like, this square root of like gamma square minus 4 mk over 2m is less number than gamma over 2m. Does it make sense? So like big negative value plus small positive value, which means R1 is also negative value, right? So since my R1 and R2, both of them are negative, what does that mean? I'm talking about the exponent R1 and R2 are negative. Then my UT goes to 0 as t goes to infinite. Does it make sense? Okay. So, well, like not only this one, we can talk a little bit more. Okay. Look at that. What about U prime? Okay. We're going to talk about like, the local maximum and local minimum, something like that. Okay. And do you remember when you talk, like when you learn about this one, like, I'm talking about calculus one. Okay. Or when we talked about finding local maximum, local minimum, there are like a couple of steps which is important, right? So what was the first step to find local maximum, local maximum, local minimum, local extrema? Okay, what was the first step? You take the derivative to find the critical number, because critical numbers are all the candidate for local extrema, right? So we're going to do that, okay? Take like derivative of your solution curve, and that is equal to a r1 e to the r1t plus b r2 e to the r2t. When I factor e to the r1t out, and this can be written by e to the r1t, and we have a r1 plus b r2 times e to the r2 minus r1t, r2t minus r1t, something like that. Does it make sense? Okay. And okay, let me come back. Like to find the local maximum, local minimum, we had to find the critical number first, right? Critical number means like u prime must be equal to 0. Okay. But look at that. Like first term e to the r1t never be equal to 0, as you know, right? Then to make this one, there's only one possible case is here, right? Does it make sense? Okay. But like from this one, as you can see, like even it looks a little bit complicated, but it's not that complicated, because like this is just like a simple equation that equals 0, then with only one unknown variable t, right? So we can say your u prime is 0 for at most one value of t, right? Does it make sense? But wait a minute, this doesn't make sense, right? Because look at that. Look at the previous motion, right? Look at that. When you look at this graph, like there are like, many local maximum, local minimum, okay? Which means when you like find u prime and set that equals 0, you could have like many like 0 points, right? But in overdamped motion case, you have only one solution for u prime, which means you have only one critical number, right? What does that mean? In other words, there is no oscillation, okay? Actually, if you draw the graph of this one, I mean like graph of ut itself, and the solution curve looks like that. Does it make sense? You're gonna have only one critical value, right? So like, what does that mean? Since it is like, too strong damping, which is overdamped motion, that's why there is no oscillation, okay? So we can say, right? Okay, let me keep talking about oh no, like let's talk about like critically damped motion in the next video, okay?